So yeah, um, so today's session is going to be really exciting because we are going to cover a lot, like starting with the distinctive features of Gemini. We will dive deep into how to use these APIs as developers, and then we will use Google's AI Studio as well as Vertex AI to pull in these Gemini APIs and then use them to create some sort of chatbots. And we'll play with a lot of data modalities, text, images, video to see the power of Gemini in action. And then we will also do some sort of vector matching. Um, and then we will like design another web application that pops up some top 10 relevant matches depending upon some input, some prompt that we'll be giving to one of the bots that we'll train. So really excited. There's a lot that we'll cover today, and let's get going with it. Okay, so let me share my screen. So this is the Google Drive link. Let me share real quick this link with you all. Just making sure that it's available for everybody. Awesome. So here we go. I've shared this Google Drive link on the chat. So you will be now able to access this drive and all the content within this drive. So this is all we are going to use. This is all the content and all the resources that we are going to be using for today's workshop. Okay, so let's walk over some of the things that are here within this drive. So if you click here, this is a slide in two formats, PPT and PDF. You can use either depending upon what you're comfortable with. Yeah, I'll zoom in to make it more visible. Okay, I think this is better. Okay. Okay, so one thing that I would like to go through, and that is one of my previous workshops that I did was about building a RAG-powered chatbot, and then a deep dive into this concept called self-RAG. So this was a paper that came in, I think, February, or maybe I think December last year. And it was about like self-reflection and how it improves the traditional RAG. And then I used OpenAI embedding models to like create a chatbot that is RAG powered. So today we are going to do that. One part of the demo session we'll be building a chatbot which will be RAG powered, but instead of using OpenAI, this time we'll be using Google Gemini family of models. Okay. So quickly, I wanted to go over the basic highlight of this so that you will understand what's happening once we get to the coding part of it. In LLMs, I'll give a very quick overview because it's applicable to the whole. Somebody's saying I shared the notebook instead of the drive link. Let me make sure that indeed that's the case. Give me one sec. So this is RAG workshop folder, and I'm resharing it again here. So if I click here, it goes to this drive. So it's coming to the right link. So that means it's the right link, right? Let me check the previous link where is it? Here. Yeah, you're right. The previous was the Google Colab link. So that's not the right link. Thanks for letting me know. That was a good catch. Okay, so this time we have the whole drive link. And now you have access to the slides as well as all the other files that are going to be used during the demo session. In this chat, I've just shared here in this chat. So Zoom chat, you'll find the link to the drive. Okay, now check now. I shared with everybody. Awesome. Okay. Okay, so these are the slides, and I was talking about the slides. So once you click on the drive, double click on the slides, and then it will take you to the set of slides. Okay. And if you go to the last slide, there's a link for this YouTube channel, right? So it's
So what is
so this is the Rockset YouTube channel. All the workshops that we do, the recordings are available on this channel. So if you go here, you can subscribe if you would like. And if you go to the videos section, this is the RAG-powered recording. Okay. So you can watch it later if you would like, if you're interested in RAG-powered, building RAG-powered chatbots. Okay. Okay. So what I was saying is, yeah, I'll go slow. Okay. So I was saying you can use this link to go to the YouTube channel where we keep all the recordings. Click on the video section and check the RAG-powered chatbot building session or the self-RAG deep dive session. It's actually one in the same session. And in this session, I created a chatbot that was powered by RAG, but that time I used OpenAI embedding models. But this time in this workshop, one of the demos that we're going to do, we'll be using Google Gemini instead of OpenAI embedding models. Okay, so that's one part of what we're going to do. So going back to my slides here, I would like to cover some basics before we dive deep into like the Gemini and the building part of it. So those basics are I think everybody here understands what is an LLM, a large language model. It's like a very large neural network, more specifically a transformer network that is trained on a large corpus of text data and a lot of times on a lot of image data as well. And nowadays on multimodal data, including video data, right? So that is the high level of what an LLM is and how it's trained. And then these LLMs, they have a cutoff time, which means that around some time, the training data is restricted to some sort of timestamp. After that time, the LLM, whatever the events might have happened in the world, the LLM has no information of whatsoever happened after that date, right? So that's called the training cutoff. So in order to improve the LLMs and have the more context of the recent events, there's something called RAG that was introduced, retrieval augmented generation. So what RAG enables and or facilitates is, which is to add an external knowledge base to the existing LLM so that this new knowledge base can be used by the LLM to generate better responses, right? So now that you understand RAG, you will be able to understand during the demo session when we will be using this concept to build a chatbot. Okay. So this is how the chatbot is going to look like. We will prompt it with something, and then it will generate a response that will look like this. And it will all happen on the browser. So you would not have to have like any local configuration done. We'll just use Google Collaboratory, and it will all happen on your web browser. Okay, so you can go through these slides later if you are interested in RAG, self-RAG, how RAG and self-RAG are differentiated from each other. But let's come back to the Google Gemini part of this workshop. So when Google released Gemini 1.5, they also released a report along with that titled Unlocking Multimodal Understanding Across Millions of Tokens of Context. So let's go through this report to understand the distinctive features of Google Gemini and then how it's different from other models like other large language models like OpenAI or Claude. So I'll quickly open this paper. For you guys, you can uh, just type the title of the paper and Google it and download the PDF. So you can just go on typing unlocking Gemini 1.5 and it should pop up here. So if you click on it, you will go to the archive. You can download or view the PDF here. I'll just share this link directly so that if you would like, you can go here. Okay, so let's go over some of the very interesting things about Gemini here. So the first remarkable thing is, unlike other models, Google boasts that Gemini is capable of recalling and reasoning over fine-grained information over millions of tokens of context, including multiple long documents and hours of video and audio. So what that means is you will have, I already shared the article link. Let me reshare it if you didn't get it here. Okay, so what that means is Gemini 1.5 Pro, it has a very, very large context window of 1 million of 10 million tokens. So if you recall, then GPT-4 Turbo had 128,000 context window. So 10 million as compared to 128,000 is like really large. So that's one of the very distinctive feature that you have to know about Google Gemini 1.5 models. And if you go on second page, you will see this video. So 10 million tokens is almost equivalent to a 3 hours length of video in like normal, maybe like 30 FPS. So it's like 2.3 hours is like 2.8 million tokens, depending upon the FPS. And then for audio, it's like 22 hours. And then for text, it's like 7 million words, right? So what Google did was they uploaded this 3 hours video, 22 hours of audio, and 7 million words as text and tested Gemini 1.5 Pro's recall ability. And then they noticed how like it had a precision of 99.7%. So it's like finding a haystack in the needle, a needle in the haystack. And this haystack is not just text corpus, it's like multimodal corpus, including videos, audio, or text. And in all the three modalities, it was like almost a perfect recall. As you can see, like even in like 7 million words, which is like 0.2% of the whole Wikipedia that we have on the internet, we only see like a few red dot marks, which means only a few misses of recall. So if you would have to type like, hey, find me all the scenes in this movie where Sean is driving a red car. So it will have like that perfect, almost like near perfect recall for that video instance if you upload like, let's say Fast and the Furious movie. Or if you have like an audio worth of like 22 hours length, and if you search for one line, then it will be almost like perfect recall for that one line in that 22 hours of audio. So that's something really worth noticing about Gemini 1.5. Okay, second thing so after this near perfect retrieval, second thing that I would like to add is uh, this mixture of experts architecture that Gemini is based upon. So what this mixture, so you might have, so there was this recent paper that was released by Mistral AI in February that talk in detail about mixture of experts architecture. In short, at a high level, mixture of experts architecture means like you have like a bunch of neural networks, small neural networks that can work as one unit to generate responses. For example, one neural network can deal with text corpus. One neural network might be trained to read code, write code. Another neural network might be specialized for audio modality or video modality, video understanding, right? So these small neural networks are specifically trained in to work together coherently so that the whole large language model can give you great responses and reasoning abilities on all the multimodal data that you might be inputting, be it a text prompt, be it a video and a text prompt, be it a combination of audio, video, and a text prompt. So this is all we are going to see during our demo session, and we'll be prompting Gemini with different sort of modalities, and we'll see how it responds to them. But yeah, for now, it's worth noting that this mixture of experts architecture enables Gemini to be trained quite effectively in short amount of time in a very distributed fashion. And then it also gives the architecture several inherent advantages when it comes to dealing with multimodal data. Okay, one interesting thing that I would like that I would like to highlight here is this. If you see this, the advantage of such a long context are tremendous. For example, you can give a whole grammar book and a dictionary, like which is almost like 250,000 tokens in this case, and then have this long form context for this Gemini model to be used while prompting it to give you like some really cool output, generative output. Like for example, here, what they did as an experimentation was to give it the whole Calamang dictionary and a grammar book for this Calamang language. So this is some sort of rare language that they picked up from somewhere. And then they gave this whole context in the form of a grammar book and a dictionary to Gemini. And then they tested with a bunch of English prompts and then tried to see how effective the translation of this to Calamang was. So this is like really interesting how, because of this 10 million tokens context window, you have the power to even like give it an entire dictionary and grammar book and have it translate almost anything using it, right? So you can think of like giving it like a whole database of things that you might have and then ask it to perform numerous cool operations on that database. Or you can give it your video catalog. You might have like your marriage video catalog or whatever, and then ask it like different sorts of prompts like, hey, can you pick up this scene from this video catalog that I've given you? So, like it's just, there's no limit to this kind of uh, setup where you have such a huge context window. Okay, let me go through some of the shortcomings of this model because uh, it's important to also discuss some of the downsides of this model. But before that, let me quickly add this. One thing that is also very cool about it. So Gemini, if you see here, this log likelihood, this negative log likelihood is decreasing with the number of tokens that we are providing Gemini, which means so let's go back to that dictionary case. If you're passing it the whole dictionary, you're giving it a large context, the accuracy of the model is increasing. So decreasing negative log likelihood means the error rate is decreasing and the precision is increasing. So that means the more context you give Gemini, the more accurate it becomes in generating the output. So generally what we have noticed in a lot of LLMs is they struggle with giving you high quality responses when you have large context windows and you give it a lot of input. But that's not the case with Google Gemini family of models, apparently, because it is able to like have more precision with more context given to it. So that's a cool thing. Okay, so one thing that I know necessarily is I'm very fond of when it comes to Gemini is the guardrailing. So let me put that keyword here and see where that section is. Okay, just can't find guardrail as a keyword. So what Google has done is like they've increased the guardrail around the model because of the past experiences with existing LLMs that we have. Like people try to jailbreak, people try to like have them generate some sort of biased responses. So the guardrails around Gemini family of models are really high. And that's something that is a little uncool about Gemini 1.5 models. And in general, the whole family of Gemini models. So a lot of times when you will ask it to generate some specific responses, it might actually deny generating those responses. And we will see that during the demo. And that happens because of these guardrails. So I'm trying to actually go through that uh, slide where it talks about these guardrails and denying all these. I think it was page 28 here. Gemini 1.5 Pro has higher refusal rates on both grounded and ungrounded questions. So that means there's a good likelihood that if you try to jailbreak it, it will not work. And then if you try to like ask it to compare like American presidents, Donald Trump with somebody else, then it will likely not give you a lot of those answers. Anyways, I think in the interest of time, we should move on to the the configuration part of the workshop to get going with the coding and generating some cool responses out of this family of models. So, but this is an interesting report, and definitely consider reading more of it whenever you get a time. Okay, so let's go back to the slides here. And again, the Google Drive. So here's the Google Drive. So again, you can click here on the last slide. It will take you to the Google Drive. Okay, slide number 6, Google Drive. And once you go here, uh, click on this notebook, RAG chatbot notebook. So there are two notebooks. One is this RAG chatbot, and one is this Google Gemini. Click on this Google Gemini one, double click, and it'll take you to Google Colab. Yeah, somebody said that they have joined late and they want the slide link, so I'm resharing this again. Here we go. Okay, so once you double click on this Gemini notebook, your Google Colab will be launched and this notebook will be displayed on the screen. So this is the one that we're gonna use for today's demo. So this has all the code that we will be uh, using today. Hey, can you guys confirm if this code somebody said it doesn't work? Can you confirm if this notebook indeed does open for everybody? Works? Okay, awesome. Okay, so now, so the problem is we can't directly run this notebook in Google Colab because when you try to import Vertex AI, there will be a lot of configuration that will be needed explicitly, and you still will have to sign up for Vertex AI in order to run it in Colab. So ideally, what I recommend to do is running this within the Vertex AIs. So let's start an instance of Vertex AI and spin this notebook under Google's Vertex AI. Okay. Uh, so what I'm gonna go do is go to my Vertex AI console. So for you guys, what you can do is either Google search Vertex AI Google, just Google Vertex AI, or just type this URL. Yeah, so Vertex AI is something that Google offers to build and use generative AI, right? So whenever you want to build generative AI solutions, then all the foundation models that you use can be pulled up using Vertex AI. It's like a unified AI platform that enables you to use Google's LLMs and all the generative models, be it an image model, text to image model, right? So all this is available within generative AI. Okay, now that you have this link, click on this link. So for me, when I click on go to console, it takes me to something like this. But for you, if you have already used generative AI, then you will see this console. Otherwise, for you, it will be like this. Try Vertex for free. So what you can do is you will get 300 credits for free to spend on Vertex AI. So just click on try Vertex AI, sign in using your email. Like for example, I can just use one of my emails and it's saying it's not finding. Okay, this one. So once you sign in, you will see this kind of a dashboard. And then you can click on here and check if your first project is selected. And then click on Vertex AI Enable. And it will ask you to enable billing. So that's an issue. So for solving this, you'll have to click on Go to Billing and then link a billing account, manage billing accounts. I'll just directly paste this for you guys in the chat. So you will have to create a new billing account like this. Click continue. And then it asks you some credit card information, which is something new that it should. Okay, so for providing $300, I think they are asking you to add a credit card. Although this is not going to be charged because during this session, we're going to use some 10 cents, 30 cents, or maximum $1. So we're not going to run out of $300 by any means. So you feel free to add any random card or, I mean, whatever card you have, because I don't think it's going to let you go through this Vertex AI usage unless you add and use your $300 credit, free credit, unless you add some credit card. But yeah, you would have to submit and enable billing in order to use Vertex AI. If you guys are not, like you don't have a credit card or debit card handy, then just run using a normal Google Colab. Don't use like this one. Don't use Google Vertex AI. And then later, when you get time, you can actually go and try this out on a Vertex AI. You would be able to run most of the cells using Colab, but some of the last ones where we will be running the web application, those will not be able to, you won't be able to spin those applications. But yeah, a lot of the code that we have written will still be applicable and it will run in Google Collaboratory. Okay, so let's get back to this, submit and enable billing. So once you are done with all this, you can go back to uh, the Vertex AI console, which is this, and then click on Collab Enterprise. So can somebody confirm if they're able to follow along and find all this and find all these interfaces? Works. Okay, nice. Okay, so now after clicking on Google Colab Enterprise, you will have to upload my notebook here. So click on this and select the notebook from your local. So you would have to go back to the Google Drive that I shared. And from this Google Drive, what you can do is download this here, Google Gemini 1 from the Google Drive. Again, I'll share. And then once you download it, you will be able to upload this notebook here from the same location wherever you have downloaded it. So upload it here, give it a name, click on upload, and then that notebook will be displayed here on the left nav. Okay, so I will click on the notebook, and then it's loading. And here we go. Okay, once it's loaded, what you can do is run the cell. It'll start connecting to, and it will start allocating the resources like RAM, GPUs. In this case, we don't need GPUs because we're not going to train the model. Instead, we're going to just use the inference for the model. But yeah, so by the time this runs, let's go over to the next configuration piece, and that is getting the API key from Google AI Studio. So let me share the link again here in the chat. So this API key is going to enable you to use the Gemini 1.5 or 1.0 API suite. So go to this link and then get your API key by creating a new API key. Select the same project that you have in your Vertex AI. So for this, go to your Vertex AI, check here the project. So HYK server 1 is the one for me. So I'll select the same one here, HYK server 1, and then I'll generate a new API key. Okay. Okay, once you generate the API key, just copy that and paste it in the notebook. So here's the notebook, and here's where you can paste your API key. Here. So paste it here. Okay. So this might take a little bit of time to connect because Google enables 3 sets of APIs in order to run these cells. So it will take a little bit of time for it to enable those APIs within the Vertex AI, and then it will be able to kick off. So somebody's asking how I imported Google Colab. So click here on the upload button, select the notebook in your local, and you will have to download the notebook from the Google Drive link that I've shared. So here, click download, and then we download to your local, and then go upload it using this link here within the Vertex. Okay. Okay, so let's go over some of the code pieces here. So this is just installing the dependencies, the generative AI models. And then here, what we are doing is, so whenever we give a prompt, the output is in the form of a JSON. To just make it look neat, what we are doing is turning that JSON output to a markdown format. So that's what this function is doing. Okay, so this is a list of models that I'm displaying here in this cell. So whatever models are available in this to you in your account, they will be displayed here. So if you already like signed up for 1.5, then you will even have access to 1.5 Pro. Okay, so let's, I'm still like not sure why it's loading for so long. I'll just connect to a runtime manually. Somebody's asking if I can repeat the API configuration. Yeah, so here you go to the aistudio.google.com, this link, and then click on Get API Key, click on Create API Key, type in the name of the project, the Vertex AI project, and then click on Create API Key in existing project. And that's how you will have this new API key, copy it, and paste it in your Vertex AI. Yeah, so this is the thing. Like, I think I'll go through everything and then I will address the questions. Otherwise, you'll just stuck in the configuration part. Okay, so let me really quick run this whole notebook. For some reason, the Google servers are really slow and it's still connecting. Okay, let's just run the Google Colab by the time it's connecting. So I'll execute the first cell. Okay, so Google Colab was pretty fast. It allocated the resources pretty quickly. But here in the Vertex AI, it's still like connecting. I'm not really sure why it's not allocating resources, but it should. Okay, so running cell by cell everything. So as you can see, all the dependencies are now installed. And these are the available family of models. And we are ready to generate our first text. So I'm asking, what is the meaning of life? And I'm using Gemini Pro from this list, this model. And then here you go, you get a response. The meaning of life is a deeply philosophical and personal question, and blah, blah, blah. So yeah, you can definitely play with a lot of such prompts and see what kind of responses you get for what models. Again, executing this cell. This time I've added one more parameter called stream equals to true, which means, so when you use the ChatGPT interface, you might have seen that it doesn't give you the whole answer at once, right? It's a running stream of generation. So if you enable this parameter, then it gives you like a running stream instead of like the whole thing at once. So that's what it does. It's just the nature of Google Colab that it seems to be coming all at once, but in reality, it's actually generating character by character. Okay, let's keep running all these cells. So as you can see, when I ran this cell, you can see like different kind of parameters here, like safety rating, citation metadata. So with every response object that you have, there's a safety attribute that is connected to that object. So that means like Google has specifically crafted their API suite in a way that your safety and security will always be measured for every response that you generate. So if there's a threat, if like there's some sort of hate speech, then the prompt will not be generated, then the response will not be generated. So there's like a threshold of these categories beyond which, if it reaches that threshold, then it will not generate the response. Okay, let's keep running. all these. Okay, so this is the curl image. So I'm just taking one image from this URL and then giving it to Gemini so that Gemini can describe what it sees in this image. So using Gemini Pro Vision model and then giving it and then asking it to like describe the contents of this image. So as you can see, there are lunch boxes with some broccoli, carrots, rice in there. And then the output that it gives me is chicken teriyaki meal prep bowls with brown rice, roasted broccoli, and bell peppers. It's just quite good. Okay, so here I'm asking it to give me a short, engaging blog post based on this picture. So it's giving me that blog post now. So let's keep going with these. Here I'm asking it to give me detailed explanation of how computer works to a high schooler, to a young child, and it gives me all that at different levels. So yeah, you can play with all these, but the idea was to like show you guys how you can use uh, the API suite and Google Gemini family of models to like generate all these different outputs. Okay, so let's go through this piece embedding now. So here what I'm doing is uh, vectorizing this input, and this is how the output looks. So an embedding is created for this input, and then now I give it a more content by adding more prompts, like a set of prompts, and then I ask it to vectorize the whole list. So it gives me all the vectors corresponding to all the prompts. And then I can use an embedding model to ask it to like give me the most important matching results from this embedding, right? So let's say you have like 10 items. Let's say you have thousands of items in your catalog and you want top 10 recommendations depending upon some prompts that you have given. So that's where vector matching happens. So what we can do is apply some sort of similarity matching and then have, depending upon the vectors generated for your input query, as well as the catalog of data that you have, or product or whatever kind of data you have. And then depending upon the top 10, 20, 50, however many you want, the best matches will be displayed. So that's another use case that you might have come across a lot of times, vector matching. So that's this. Okay, so let's keep running. So pip install Streamlit. So we are installing Streamlit to render a web application. So what Streamlit does is it will be able to render a web application and spin an instance within the web browser itself corresponding to this app.py file that we wrote. So I'll keep running all this. Okay, so I was checking, it's still not connecting in the Vertex AI for some reason, which is hilarious. It should never take this much time, but for some reason it's not connecting. So all the configuration, as you can see, is good, but still for some reason it's not connecting. Let me just change the region and see if it connects for some. Okay, so when I change the region, as you can see, like my notebook disappeared because for the region, the configuration has to be done separately. So I'm uploading my notebook again. So I did upload the notebook and it's loading here. It did load it. And now I'll run the first cell to see if it connects this time. Okay, by the time it connects, let's go back to our Google Colab and run the remaining cells. So we ran this local tunnel for Streamlit, and now we are gonna install a few more dependencies so that Streamlit works properly in Google Colab. So as you can see, it's asking me for yes or no, and I have no way to type. So what I'm gonna do is just stop this cell and it will install anyways. So it keeps on installing. When I click the stop button, still connecting. Okay, now I'm gonna run the Streamlit server. So here it gave me an IP, and it's gonna give me a URL that is associated with this port. So I click here, I click on the IP and copy this IP here into this password, tunnel password, and then click on submit. And it will launch the web application using Streamlit. So it's all running in your browser. There's no local dependency on operating system or whatsoever. Okay, so here is the interface that I've designed. So there are 4 things that I have designed. One is generating a story. So if you enter a character name, you type in the character, a personality, and some location for the character and some premise, and then configure, then you can generate a long or short story depending upon all this configuration. So as you can see, it's not finding the resource because I'm running it on Google Colab. And with Google Colab, that's what happens. So like if you try to run without Vertex AI, then it cannot pull up your Gemini Pro models, and that's the problem that it gives. So this is why you will have to go through uh, that all that 300 credits use in Google Colab Enterprise, and then you'll have to put in your credit card information and then use your free 300 credits to within Vertex AI to run all this. So as you can see now, finally, I'm connected to this new region that I configured. So we can quickly go through all that and do the same and run this application within Vertex AI this time. So let's see if it works in Vertex AI. So I'm running the same stuff, but I'll skip all this and I'll go to the Streamlit part. So install Streamlit, app.py, local tunnel, and then finally running the Streamlit server here. Okay, awesome. So let's open this, copy paste the IP as the password again. Okay, so it's giving me an error and endpoint IP is not correct. So that happens sometimes because of some sort of browser cookie configuration stuff. So what you can do is use Safari or some other browser, copy paste the same URL, enter, type in your password, copy paste the same password, and click on submit. So here you see it works because the cookie or whatever the configuration of the browser that was, or maybe some sort of firewall or some sort of VPN you might be using. So changing the browser works there. So it's spinning off the web application. So you see the same web application. Now this time it should generate because I'm using it within Vertex AI. Yeah, it succeeded generating your story using 1.0 Pro. So as you can see, this time we succeeded in generating our story. So that is the problem, guys. I'm not really sure why Google has this problem that we cannot use Colab because it doesn't let us pull the resources, the Google Gemini Pro models, without having to use all this code within the Vertex AI Google Colab Enterprise. So this was the error we were getting. But here, when we use within Vertex AI, as you can see, like it's successfully spinning up the instance, and we have the generated response. So this is the story that we have generated in response to all the configurations that we have done and all the inputs we have given. So if you click on the prompt, see, this is all the prompt that was given as input to the model. And I generated all this prompt using all this, all the inputs from all these fields. So this is the prompt, and it writes a short story given all these contexts. Similarly, you can design a marketing campaign, name of some of your product, like electronic, let's say Apple Watch or something. And then generate my campaign. So it's generating my marketing campaign. The prompt that was given was this. And this is the campaign that it generated. So it gives me some steps to promote this product successfully to this specific audience with this goal. So as you can see, the magic of a large context window is really awesome. Like you can give it a lot of context and the precision doesn't reduce because now it's capable of like 10 million tokens, right? So that's the power of Gemini. So now here in this image playground, I have given it a set of images of furniture, and then I'm asking it to like recommend me the chair that best fits my living room. So this is the image of my living room. So these are the options that I'm giving in when it comes to chair. And then I'm asking him, hey, what do you think best fits my living room? So if I generate the recommendation, it will give me like some sort of response. So it's giving me a reason for every selection that it has made. It's giving me some sort of reasoning that, hey, this chair is suitable because of that. It's not suitable because of this. So yeah, feel free to play with all this. Owen instructions, ER diagrams, glass recommendations, math reasoning. So I've designed like different interfaces with different set of configurations to generate different prompts. And then you can play with them and see what kind of outputs you get. One last thing I would want to show is this video playground. So if I play this video, this is the input video that I'm giving this model, and then I'm asking it to generate the description of this video. And also give me some top 5 similar places in the world that I can go visit as I like this place, right? So let me generate this real quick. So all this I have built here. So you see this app.py, all the code for all this interface lies in this app.py cell. So all this comes from here. And then I'm using Streamlit to just spin off this web application using the browser itself, utilizing this app.py file that I have written. So as you can see, it generated the response. The video is of a beautiful coastline with a rocky cliff, blah, blah, blah. And it gives me the location, and it gives me top 5 places like that. Quite amazing. Okay, so this is the first part of the demo. I hope you learned something from it. Now let's go to the second part of the demo and do some vector matching. So I'll stop this Streamlit instance and I'll install this dependency, this LangChain. So I'll give you a high level of what's going to happen with the second part of the demo. So what we are doing is we are taking a video game database that is an open source database of some Amazon video game products. And I'm gonna give an input query and ask the bot, which in case is the Google Gemini family of bots, family of models, to give me the top 10 matching video games depending upon my prompt. So what I'll do is, so all these video games have a description field, and when I prompt, uh, then the system will match my prompt with the description of the video games, and whoever and whatever matches the most, it will pull up the top 10 matching video games depending upon my prompt, right? So this is a vector matching. So this is an overview of the vector matching part. Okay, so now you have like uh, an idea of like what kind of vector matching is happening. Let's run all this. So the output, so what I'm gonna do is again use Streamlit, and the Streamlit will render an HTML file on the browser itself, and that HTML file will have like a neat interface. And on that interface, I'll display all those 10 recommended video games. Okay, so let's go over this. Okay, so the problem here is we would have to vectorize these video games for vector matching, and these vectors will have to be stored somewhere. So for storing these vectors, we need some sort of a vector database. So for the purpose of this demo, we're going to be using Rockset as a vector database, and then Gemini. Gemini, you already know, like Gemini family of models we'll be using to like vectorize these video game descriptions, and for storing them, we'll use Rockset. Okay. Okay, let's just do it. So I'm running Streamlit. I'm installing the dependencies, which are like LangChain, PyPDF, and Streamlit. And I'm going to install Rockset, which is our vector database in this case. And then I'll go to rockset.com and click try free. So now you can sign up for Rockset, and you will get like $300 of credit again. But this time you would not have to insert your credit card. So you can just type your details, your email, some random password, and click on get started for free. I'll just type the link on the chat, this one. So it's asking me to verify the link. So you'll have to quickly do that. Let me just quickly go to my inbox and do that. Okay, now you're gonna click on here, API keys, create your API key, type in some name like sample, test, or whatever you would like. Click on admin here, set it to never expire, and then click on submit. And then copy and go to the notebook again here, and then type and then put your API key here, and Rockset API key here. Just type, copy paste here. Okay. So the Google API key remains as the same, the previous one that you have used. And then the Rockset one, we just copy paste it. And I'll run this cell. And I'll just keep running all these cells. So this I've already explained. So what we are doing is some sort of vector matching. And we are recommending top 10 items. Okay, so it's saying that this file is not found because what we're doing is we are using RAG, which means we are giving it a PDF file here, and then we are asking it to use this PDF file to generate a response. So what I'll have to do is upload here that external file. So for that, I'll have to go back to my Google Drive here and fetch that airag.pdf here. So download airag.pdf and go back to the Vertex AI, upload, click on plus. So it gives this file. Wait, don't click on plus, just upload wherever you have this PDF, AI RAG, just drop it here. Hold on, give me 1 sec. Create. And okay, so click here. You see a bunch of files here, right? Now drop your AI PDF here. It will give you a warning. Just click OK. And then it will just upload your file here from your local. So now we are ready to like utilize this file. And as you can see, it's run successfully this time. Cool. So I'll keep running the vector matching code. And now it's giving me another error. That error is because of the configuration. Okay, so let's change this configuration because it's the region problem. It's not finding the appropriate region. Let's check this query. So the configuration is forbidden, which means the key that we are using is not being supported. Let me just change the key to the one that we generated. So for you guys, it should run actually because you have the right key. For me, it's just I have used a Google account that is different from the one that I'm signing in using Rockset, signing in with Rockset. So that's why the discrepancy is happening. But yeah, once you paste the right key, you will be able to run this cell. And the same workflow follows. Like this is an app.py. This is the application file here. I've named it as main.py instead of app.py. And then you will run the Streamlit again, and there will be a URL. Once you run the URL, you will enter the same sort of password, and it will take you to the same sort of chatbot, and you will be able to like run your vector matching stuff here. and it will like display that interface with the recommendations. Okay, so let me go back to the chat to see if you guys are able to like catch up and run all this or not. And if there's any error, then let's solve it. Okay, so let's see. Rockset part is not clear. The API is not available in my region. Are you talking the Rockset API or the Google Gemini one? Google one, yeah. Okay, sorry, no stop at API Gemini. Yeah, so that might be a problem. In some areas, Google might not have opened their Gemini family. That's a problem with. So in that case, what you could do is use um, OpenAI, OpenAI model, at least for the embedding part of the workshop. Instead of using Google Gemini, you can just use OpenAI embeddings. Okay, let me let me show you the let me show you that part later using OpenAI as well, so that you can like for the ones for whom it doesn't, the Google Gemini APIs don't work, they can at least pull up the OpenAI embedding models and use them to generate the response. So I'll go through that, but before that, let me go through some of the questions. If somebody has some questions for the set of things that we did. What does Rockset do in this project? Okay, so what Rockset does is it's a vector database. And whenever, so you saw there's a catalog of items, right? Like say here. Okay, let me go back to the code here. So if you see this piece of code, what we are doing is this PDF that we are uploading, we are chunking. So we are converting. So we are tokenizing all the content of this PDF. So whenever there's a text found in this PDF, it will tokenize all the text and then split the text, the tokenized text into 1,000 characters wide chunks. So equal size chunks of 1,000 character long. And then 17 such chunks are found and created, and they are stored in the form of vectors. So the text is converted into a numerical representation because these AI models, they don't understand text. What they understand is some numerical representation. So what we're doing is we are chunking these texts into equal sizes and then converting them into a bunch of vectors, numerical vectors. And then finally, this set of vectors are stored in a database called vector database. And for this demo, we are using Rockset as that vector database. So what Rockset does is it efficiently and effectively stores these vectors corresponding to your data set that you have uploaded, which in this case was this PDF, right? And then whenever you input a query, so this is my search query, right? That I give to the LLM. So this is the input query that gets vectorized as well, like this, right? And then a vector matching happens. So it matches this vector along with these vectors, these 17 chunks, and then it pulls up the most relevant, the most similar vectors, right? So that's what happens behind the scenes. So what Rockset does is it effectively and efficiently stores these vectors. And then when you retrieve, it it gives you almost near real-time performance during retrieval. Okay, let's see if there are any other questions. Somebody's asking, Vijay is asking if Chroma can be used here in concert with vector dot. Yep, you can use any vector database. It just depends on your preferences. Okay, so I just realized that my screen was not shared. It got disabled, but now I think you guys can see my screen, right? Okay, let me repeat this again. So if you see this part of the code, we uploaded this PDF file, airag.pdf, and what we did was we scanned this PDF file for text, and when we found this text, so we use LangChain to get the text to read this whole to read all the pages of this PDF file, and then we extracted all the text within those pages, and then we chunked them into equal sized chunks, and then we found there were 17 chunks that came out, and then we vectorized these chunks because these LLMs, they can't understand text. So they need a vectorized form as input. So that's what we do. We vectorize all the PDF content. And then on the other side, the search query that you will prompt LLM with, you vectorize that as well. And then you use some sort of similarity function like cosine similarity, and then you match all the chunks with your prompt to see what are the most relevant matches. So whatever the most relevant content is found in the PDF that is retrieved, that is given, right? So top matching chunks will be given out by the LLM. So this is what is happening behind the scenes. And Rockset, which is a vector database, what it does is it stores these chunks as vectors, and then it gives you a near real-time performance by retrieving these vectors that matched your input query. Yeah, so all the notebook, this notebook is the same notebook, and it is there in the Google Drive that I shared earlier. Okay, let me go through if there's any other question before I show you the vector matching demo part again with OpenAI models. Okay, I think I will proceed towards the demo part using OpenAI for the ones who could not access Google family of Gemini models because of the area restrictions. Okay, so let's go to my Google Drive again. Here's the Google Drive. And this time, let's run the other notebook, this one, Rockset RAG chatbot. Double click here, and it will spin up Google Colab. And then run the first cell. Click on this folder, go back to the Google Drive, and this time, this Microsoft Annual Report 2022, you will have to download this file. And come back here. And I'll just put this from my local here. Click OK. So I uploaded this PDF into my Google Colab storage. And then now I'll run the subsequent cells. So this time, instead of Google Gemini family of models, you can use OpenAI embeddings. So I'll use OpenAI. And the key you will have to use is the OpenAI key. You can use my key for now, just to save time. Okay, so I will run this. So same thing is happening. This time, instead of using the other AI PDF, we are using this Microsoft annual report PDF, and we are chunking and doing the same sort of things. See, it's saying no such file found because the name is one. So we'll have to rename to 2022, right? Because here the name is 2022, and now it should read the file. Okay, so it's now reading the file and chunking and generating the embeddings. So by that time, okay, so there's incorrect API key provided. Okay, so my OpenAI key has expired. Sorry, guys, because it's a previous workshop, right? So it expired, so I'll have to go and generate a new OpenAI key to use here. Let me do that real quick. Okay, so now I have API keys here, create new key, demo, create secret key, copy, done. And I'll go back to my Colab and paste here the new key. So you guys can use the same key if you want to follow along. I'll send you in the chat. So I'm running the cell again with this new key. Okay, so it's vectorizing. Your account is not active. Please check your billing details. Oh, that key also didn't work for some reason. Okay, guys, this is a thing I'm not really sure. I have the credits, but I'm not really sure why the account is disabled. But anyways, if you guys have like active accounts, then definitely you can create themselves. But yeah, I was sharing my key because I had like $50 uploaded, and for running this chatbot, it doesn't take like more than a couple of cents. So yeah, it will take like a while for me to run out of credit, so I don't mind it. But yeah, for some reason, this key is not working, so I'm not able to show you this properly. But yeah, if you guys have key, definitely feel free to run this. I'll just give you an overview of this, how it works. So this is the query. Select chunk, text embedding, and then approx dot product. So here, all the PDF file chunks, the corresponding embeddings of those chunks, we are matching them with your input query. So this is the input prompt vector, and then we are matching with all the PDF, all the chunks from the PDF, and then we retrieve the top few, and then with some sort of similarity score. And then finally, we display those matching things and then ask LLM some questions, and then it uses all these matching keywords to finally like give you some response according to whatever you asked. So like, for example, I asked it, hey, give me the financial, uh, the report for investors. So give me a summary for the report of investors. So that Microsoft annual report had some sort of like investor summary. So it gives me all the summaries, and then I can like refine this prompt further and then ask it something more. Like, for example, I can ask it to summarize the analysis or list information in the report for investors or something like that. So it will like pull up the most relevant chunks by doing a vector matching at the back end. Yeah, so this is a good question, Vijay, you're asking. Vector DB, if that vector DB can be queried using SQL statements. So vector DB, so all vector DBs have their own different ways of querying the database. Some might use their own query language, or some might use Python in some way. But for Rockset, we have our own SQL engine. So the traditional SQL syntax works with Rockset when you use it as a vector database. So that's something very cool that I really like about Rockset. And seeing my errors in real time is actually really helpful. Kaylee saying, thanks, Kaylee. That's the beauty of like live coding, live demos. Like you can see me solving errors on the fly and like trying to make things work. So that's what today's session was actually about, like trying to see how developers develop things using API Suite, and then how they get stuck, and then how they get they unstuck themselves. So if I go back to my slide, there's this blog post. Where is it? Here. Let me show you. Rockset vector search blog post. Here. So this blog post has the details of what we did today, all the theoretical details, like what is vector matching, what is vectorization, what does vector database do. So this has that neat overview diagram that will help you visualize what we were doing. So there was this Amazon product reviews dataset. It's an open source dataset. We vectorized the products here. There's search query. We vectorized our search query using OpenAI or Gemini. And then within this vector database, Rockset, what we did is we ran some sort of approximate similarity search algorithm, and then we got our top 10 matching results, right? So that's what we did. So this is some cool article that you can go through if you're interested in the details and specifics. So Balakrishna is saying, if we get advanced things to be ready before workshop, we'll save everybody time and get positive. Yeah, I totally agree. The problem is, uh, I was not sure that the credit card will be required, because when I logged in into my account, Vertex AI didn't ask me anything. So that is why, like, I never suspected that there will be a need for credit card, but something changed behind the scenes, because of which now they are offering the Google Gemini family of models in a different format, and they need a credit card on file and a project to be configured with some settings. So that's something recent that has changed, and because of that, we had to like, we could not run Google Colab, and we had to like go inside Vertex AI, upload the notebook, configure it to take the family of models, and then we had to like go through all that configuration for Google AI Studio, and then bring our API key from the AI Studio to Vertex AI. Oh, it was like a lot of configuration today. Yeah, definitely like overwhelming, I can tell. But definitely like, if you get time, check Rockset's YouTube channel. And here we have this recording of Google Gemini. In this workshop, I go through that all configuration again in a very systematic way. And I use Vertex AI, and I also use the AI Studio and do everything in a very synchronous way. So definitely feel free to watch this if you have a chance. And yeah, definitely feel free to read this report. It's very exciting. We discussed the 10 million context window and some of the distinctive features and the perfect near perfect recall. So yeah, something really exciting. So let me go through the questions that you guys have before we depart. Can somebody's asking if I can explain the overlap, why you use zero overlap in your chunking? Ah, I see. Okay, so in the PDF, if you think carefully, let's say you have like 10-page PDF and you're chunking every page into some sort of vectors, right? So if you're doing equal size chunk, for every chunk, you have a representation that contains some semantic information about that chunk, right? So whatever that chunk has, the vector contains some sort of like representation of that information, right? That the system, the machine can, these language models can understand. So if you overlap them, how do you think it will benefit the system? Like the overlapping is probably going to lead to confusion because these separate chunks are resembling different pieces of information separately, right? Equally sized chunks. And then you can match them uh, using some sort of approximate search algorithm like nearest neighbor or cosine or whatever. And then once you match, you will get the most relevant matches. But if you overlap, then how would you match it? Like there will be some sort of discrepancies now that there's overlap between those chunks, right? So it makes sense to not have any overlap. Okay, second question. Certain keywords can get cut in the middle. Yeah, that's right. Not able to get response from Rex. It says query lambda not found, although I pasted and created with the correct names. Okay, so let me go through the query lambda thing again, since you're interested. So go to the Rockset console, go to query editor, and here you can write, I'll just go with this chatbot, edit SQL. So here's the query lambda. If I run it, it runs. And okay, so what you have to do is copy paste from the Google Colab this this SQL query and then run it. And copy paste in this query editor. So what you will have to do is like create some sort of new query lambda and by copy pasting it, and then you'll have to add these parameters here. And then once that's all configured, all the parameters like this limit parameter, this query embedding parameter, right? Then you will be able to run this and then you will get all this response. So you will have to do all that configuration. In the Google,
Sorry to interrupt, Ankit. Are you sharing
yeah,
something? Your screen is not visible to us.
why my screen gets stopped? Okay, let me share again. Thanks
Okay.
for. Okay, so here in the Rockset console, if you go to the Rockset console, go to the query editor, paste your query lambda here from the Google Colab. So we open our Google Colab here, right? So you can go to the cell where we wrote this query lambda here. So I'll copy paste from here. Here, this, right? So just copy paste it and then define these parameters, limit 30, click on plus, limit type integer, value 30, right? So that's how we define this. Then we define this query embedding. what you can do is go back to Colab. This is your input query. This is the vector corresponding to your input query, right? Copy paste this whole vector, go to the query. This is the value, right? And now if I run it, limit appears to be more than once. Run it. It gives you the top matching scores, right? So this is how you do vector matching using a vector database. With Rockset, you have the advantage of using standard SQL because we have crafted our own SQL engine from scratch. And that enables you to use the traditional SQL for fetching vectors in near real time. So again, here in this blog post, we have this diagram. We vectorized using embedding model, be it Gemini or OpenAI, our catalog of products. And then we've also vectorized our input query, and then we matched and then found the top K matching. So that's what we did. Okay, let me go back to the chat. Vijay is asking, with Rockset, I don't have a chatbot, right? We just use SQL engine. No, we do have a, okay, so what we can do is, if you see the Colab link, I'll share my screen again. Here. Once we do all this matching, right, what we do is we define a RAG function and we define a retrieve information function. And then again, we use, see, this is where we vectorize the input prompt. And earlier you saw we vectorized the catalog and did the vector matching. Here I call the RAG function, and in RAG function, if you go in the, this is the prompt that I've given, and here's the client.chat.completion.create and model equal to model, message equal to model. All this code is actually using the chatbot, right? So OpenAI in this case, and Gemini in the other notebook that we used. So this model is pulling up the OpenAI chatbot, right? So if you control F, you'll be able to find where this is defined here. So this is the model from OpenAI that is being used, right? So this is the model. This is the prompt coming from here, this. And then it gives all the matching results. So what this chatbot is doing is, in addition to its own knowledge that it has been trained on, it's retrieving from the PDF that we have given it here, this PDF. So that's RAG, retrieval augmented generation. So it's augmenting its own generation by retrieving from external knowledge base, which in our case is a PDF. Make sense? Okay, somebody's asking, can we use Gemini to parse through or search from diagrams, schematics, drawings in both image or other format? Yeah, definitely, Rahul, we can. Like, so let's see if that instance is still running. Here, it's not. So we saw how, like when we ran the chatbot, you saw how like I uploaded a video and a bunch of images and gave it a bunch of prompts to ask about the best matching chairs for the room image that I've given. And for the video, like the most similar places in the world that I can visit, right? In conjunction with the video that I uploaded. So in the same way, you can use Gemini to search through different sorts of text, diagrams, schematics, drawings, artifacts, and you can upload different sorts of files in different formats. And then that's how you can like prompt it to ask about whatever you have uploaded. It could be a text, it could be a video, it could be an image, it could be a combination. Okay, let's see if there are any more questions. So query lambda I already showed. Somebody's asking where to dive deeper into RAG, both business layer and technical. Yeah, so there are a couple of awesome. So here we have this Gen AI RAG on our YouTube channel. I'll share again the link of our YouTube channel. Here, this video on our YouTube channel. So we had Devrel from Llama Index, which is a big RAG company, open source RAG company. And so we had Laurie from Llama Index, and we also had Daniel from Superlinked. That's a vector compute company. And we discuss a lot of things here, like RAG, vector databases, and the evolution that we saw in 2023 and some speculation for 2024. So feel free to watch that and you will get all these answers, like all the details of RAG in that video. Somebody asked which embedding model or method to use for image and Latin words in table format in PDF. So it depends. We could use Gemini, we could use OpenAI, it depends on your preferences. Somebody's asking how do we query from multiple sources of data? Yeah, so in the notebook that I showed, this one, the Gemini one, let me go again and see if it's running. Here, it's running, I guess. Let's generate. Oh, it's not running. So the collab problem again. In Vertex AI, it might be running. Let me check again too, so that I can show you if it's running. Yep, it's running. So you see how like in this, for generating a story, we only use text input, right? So we give it this prompt and it generates a story in response to this prompt. This interface is doing nothing but just taking all the inputs that I've given in these fields, to just fill in the blanks and generate this prompt. And then this prompt is given as input to the model to get this output, right? So same for the marketing campaigns, same for the image playground and video playground as well. But for image playground, what I gave it is not just a bunch of text, but also a set of images, right? So here, there was this text, there was this image, a reference image, and there were these additional chair images, and then I asked for a comparison. So you can have like different sorts of combinations like this: text plus image, text plus video, text plus image plus video, text plus image plus PDF file. And then you can even use RAG, like the way we uploaded that PDF file. You can do the same. You can use RAG along with your images and video, and then you can play with all this.
Ankit, someone is asking to share a screen. Are they looking for, are you expect to this to their sharing screen?
Sorry. Here. I don't know. The share screen is almost like stopped always. Okay. Here, now you can see my screen, I guess, right?
Yes.
So here, this is the same bot that we designed. The image playground section. So if you see generate story, we only give it text prompt, and then it generated this story in the form of text. But for image playground, we gave it text as well as a bunch of images, and then we asked for a comparison and a recommendation. In response to this, it gave us a recommendation of which chair it thinks will best suit our living room, right? And then it gave us a set of reasoning corresponding to every chair input that we had for it. So the question was, can we use images, PDF files, text inputs, videos? So the answer is yes. In the same way, you guys can like use RAG to input your PDF files, or you can just use the long context window to give it a lot of context on the question that you might be asking. And then you can even give it multimodal data like images, video, along with your text prompt and your PDF. So you can actually play with it in whatever way you would like.
By the way, if you have a question, you want to speak to ask questions, you can unmute yourself to speak to ask questions or do discussions. It's probably easier.
Yeah. Will there be a follow-up workshop? That Bill can tell what kind of workshops you would be organizing. I'm not sure.
Yeah, so the follow-up workshop means after this workshop, the similar topics from Ankit or probably different workshop. For us, we are running the workshop in person in many cities around the world and also virtually. You can check the website to see upcoming workshops. If you want to, I'm not sure, like for Ankit, did your workshop have a kind of like a serious workshop or something else coming up? You also can speak up on that.
Yeah. So you can, um, yeah. So you will probably be receiving emails from Bill about the future workshops. So you can stay tuned for them. So somebody's asking to show how to use images in the notebook. Okay, so I'll quickly show the same notebook that we used. So here's the Google Gemini hands-on notebook. And here's where we used images up here. So we downloaded one image from this URL, and then we used pil.image library to display it here. And then we gave Gemini Pro Vision model this image, and then we asked it to describe this image. So in this way, like you can go through the same notebook, run these set of cells, and get a response from the generative model, depending upon whatever you would like it to generate, right? So in this case, we did just a one-liner on what this image is about, and then we went ahead and wrote a short blog post on the same image. So you can like play with it in whatever fashion you would like.
So the question is for the San Francisco in-person workshops. Yes, we do have the workshops coming up in San Francisco. Check the website. I'm not sure it's scheduled yet or not, but it probably you probably will get notifications once the event got scheduled.
So somebody asked if I will upload this to GitHub for you guys to understand and appreciate the marvel of the code. Yeah, so you have the Google Drive link, right? You can anytime just go and spin this notebook in Colab and play with it, or just sign up for Google Vertex AI and then upload this notebook to Vertex AI as I showed already, and then start playing with it. So it's at your disposal anytime. And I already showed you our YouTube channel. You can always like go to the Rockset YouTube channel and see the recording of this Gemini. And that has all the step-by-step guide to how do you use Vertex AI and how do you upload this notebook and how do you spin the server using Streamlit and get all the outputs that I showed you. I'm not sure. No, this workshop will be available on AI Camp's YouTube channel, actually. Today's one. AI Camp's YouTube, Bill, can you pass them?
Yes, hold on a second.
Yeah. Awesome. Okay.
Yes, so when uh, the event is done, you're probably going to receive email notifications, follow-up emails with all the link to the YouTubes, to the all of the other resources.
Yeah. So everything that we have used, it's within the Google Drive link that I shared. And yeah, you can always like fall back to this Google Drive link and upload the resources in your current Google Colab environment and then use them. Do you know what's the difference of fine tuning by using LoRa for image to text? Oh, you mean Sora? Uh, difference of fine tuning image to text. Yeah, so that's a very different thing. Like today we have not trained any such model, right? Like we have only used these models to infer. So we have only used these APIs, the inference APIs, to like make use of the already trained models. But if you want to fine tune, that's another set of resources that you would have to use. So what you would have to do is use an open source model and then use like you use some sort of framework, like let's say PyTorch or TensorFlow, and then get a, or maybe you might use a Docker container, some sort of serving available for these models that you pick up, the open source models that you pick up, and then you can use them to fine tune on some sort of data set that you personally own, and then that way you can train a fine-tuned version of the open source model for your image to text generation task. So that's a very different sort of exercise than what we did today. Ed is saying that he still stayed without audio for first 15 minutes, but relogging and finally got the audio. Yeah, no worries, Ed. You can still watch the recording and you can go over the first 15 minutes. We did nothing more than the configuration, so you didn't miss much. Oh yeah, sorry. Sora is the other model. It is LoRa. You're right, Kaylee. So yeah, Sora is another generation model, not LoRa is a different one. So you can fine tune either. I don't know. I don't think the OpenAI has like they don't have this model Sora as open source So definitely you can fine tune that, but maybe they might introduce some APIs for you to be able to like use it for your specific context or database data set.
Just quick for the Harriet. Thanks a lot for the feedbacks, and yeah, we will put more information. So one thing for the meetup pages, because here you mentioned about the meetup pages. In general, we don't using the meetup pages for the detailed information because I think we have more than 50 meetup groups all over the world. So it's very hard to update each one. So everything should be updated on the AI Camp website, which is the one you register and get all the informations. And also later on, you can watch the recordings from the AI Camp, the event page right away. Or you can go to the YouTube link directly if you want. So yeah, we will take the feedback. Thanks.
Yeah, so this is one thing that should have been corrected. I think we would definitely be mindful of that. In the slides, we just somehow mentioned 1 hour, which should have been 2. And for the configuration, so I think this is the very first time we have such kind of a interactive coding workshop with an AI camp where like we did a lot of live coding and bug solving. So it was a very new experience. And yeah, definitely I beg your pardon that it was a little unpleasant to configure so many things all at once and different kind of frameworks and technologies, going to different sort of tabs, switching one tab to another, like from Vertex AI to Google AI Studio to Colab to this and that to Rockset sign up, right? A lot to digest, a lot to take care of in terms of configuration and setting things up to make them work to finally get the bot going. So yeah, a lot of hassle happened. But I think in the future ones, what we could do is in the agenda, we will be able to write things like, hey, Vertex AI provides $300 credits. So sign up. And we can even have like a preliminary video from me where we can go over a walkthrough of what you need to do as a preliminary step to get hands-on with the coding when the session is live, right? So I think that's a good suggestion that we can implement. And for the ones who are in different regions and the APIs are not accessible for them, I think that can also be a frustration for them. They can always like message Bill or I don't know, Bill, what kind of like I think they have a Slack channel, AI Camp. So you can always message in that Slack channel and let us know that these APIs are not available in your region. So what we could do is like find an alternative by probably changing the region in the Vertex AI configuration, or maybe using OpenAI embedding models for those folks who don't have those services in their region, right? So we could find some sort of alternative solutions like that so that during the workshop, it won't waste our time to like do things twice or go through like configuration for like first 30, 40 minutes, right? So definitely, yeah, we could do a lot in these dimensions. And thanks a lot for sharing this feedback. I think for the next one, it will be more streamlined with a lot less configuration and it will be more interactive. Somebody's asking, can a large language model be designed to prioritize corresponding with information from a specific embedding first? And if no relevant data is found, or the model is likely to help somebody without accurate information, then search within a set of embeddings for answer. Yes and no. So, what you can do is you can query the large language model in a way whether you tell it that, hey, use my external PDF to find the answer, don't use your own knowledge. Or you can tell it that, no, 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 don't use the PDF or a set of documents that I provided. Instead, just use your own knowledge. So it all depends on prompt engineering and how you prompt the LLM. So that's the best way to do such kind of things rather than like uh, making the model on its own try to do that, right? So that's likely what I'll say for such situations. Yeah, so the speed, sorry, the speed had to like in the beginning we spent like 30 minutes in configuration. At that speed we would like probably end up investing 3 hours. So that's why like I had to rush a little in the middle. And yeah, but again, like I think having you guys do some preliminary configurations for this kind of a live coding workshop will make sense for the future workshops. And we will release some sort of video or a guide for you to be able to do that on your own before coming to the workshop. And even if there are some region restrictions, we will have some alternative measures to facilitate you using some different embedding models. Let's see. Was able to get these running finally. Thanks a lot, patiently answering our questions. Yeah, my pleasure. Hope you guys learned something new today.
All right, I think we are over times already. Thank you so much. Ankit, do you have any final word for the to wrap up this workshop?
Yeah. So Bill, somebody's asking, I need to add him in case I get to SF in future, maybe your email. Yeah, so Bill, you can shoot your email to add. But yeah, the final words that I would like to say are thanks for joining, guys. It was 2 hours long workshop and there was a lot of like patience needed. There was a lot of patience that was required for the configuration and it was a lot to take in, but I am so glad that you guys stick to this for like almost more than 2 hours now and then went through the demo part as well with such an energy and enthusiasm. So just love it. It was really a great, enjoyable experience for me. And one final call out that I would want to make is my screen is still shared. So if you can see this slide, the slide number 6, it has all the links to some useful resources that you might need. But one thing that I would like to highlight is this index conference. So this is something that Bill is also gonna be actively sharing, but this is something I'm very excited about. So feel free to sign up for this. So if you are interested in vector databases, building generative AI apps, there's this conference, the whole day conference from 9 a.m. to 4:30 p.m. in the Bay Area in Mountain View, Computer History Museum on 16th of May that we are organizing. So if you are in Bay Area, definitely feel free to stop by. But if you're not, then we will have an online Zoom link for this. So if you register, you will be asked to either register online or offline, depending upon your availability. So feel free to do that if you're interested in search analytics and AI app building. And this is the line of speakers. There will be a bunch of DevRels that will be doing birds of feather discussion during the lunchtime. And that's going to be exciting. So yeah, definitely look into it. 6th slide, the link is there. I'll just share it in the chat as well. And it's free conference, 1-day conference, free to attend. And feel free to stop by or attend online, depending upon your convenience. But yeah, something exciting to look for. And shoot me an email. My email is here. If while watching the recording you get stuck, definitely shoot me an email. I'll be able to get you unstuck. I'll definitely follow up with you. And yeah, connect with me on LinkedIn. Feel free to inbox, asking any questions you might have regarding this workshop or beyond. Yeah, so excited for the future workshops to come.
All right, great. Thank you so much. Thanks, Ankit, for the host the workshop and answer all of the questions. And thank you, everyone, bear with us. And I hope you learned something so you can try it out. Just a couple of